Alright, I'm in the Pilot's Handbook of Aeronautical Knowledge. I'm on Chapter 4. This will be 4-9, Ground Effect, right after wingtip vortices. It is possible to fly an aircraft just clear of the ground or water at slightly slower speeds than the required to sustain level flight at higher altitudes. This is a result of a phenomenon better known as than understood even by some experienced pilot. This is a result of a phenomenon better known than understood even by some experienced pilot. When an aircraft in flight comes within several feet of the surface, ground or water, a change occurs in the three-dimensional flow pattern around the aircraft because the vertical component of the airflow around the wing is restricted by the surface. This alters the wing's upwash, downwash, and wingtip vortices. Ground effect then is due to the interference of the ground or water surface with the airflow patterns about the aircraft in flight. While the aerodynamic characteristics of the tail surfaces and the fuselage are altered by ground effect, the principal effect due to proximity of the ground are the changes in the aerodynamic characteristics of the wing. As the wing encounters ground effect and is maintained at a constant lift coefficient, there is consequent reduction in the upwash, downwash, and wingtip vortices. Induced drag is a result of the airfoil's work of sustaining the aircraft, and a wing or rotor lifts the aircraft simply by accelerating a mass of air downward. It is true that reduced pressure on top of an airfoil is essential to lift, but that only one of the things contributed to the overall effect of pushing an air mass downward. The more downwash there is, the harder the wing pushes the mass of air down. At high angles of attack, the amount of induced drag is high. Since the corresponds to lower airspeeds as actual flight, it can be said that induced drag predominates at low speed. However, the reduction of the wingtip vortices due to ground effect alters the span-wise lift distribution and reduces the induced angle of attack and induced drag. Therefore, the wing will require a lower angle of attack and ground effect to produce the same coefficient of lift. If a constant angle of attack is maintained, an increase in lift results, in the coefficient of the lift results. Ground effect also alters the thrust required versus velocity. Since induced drag predominates at low speeds, the reduction of induced drag due to ground effect will cause the most significant reduction of thrust required, parasite plus induced drag at low speeds. The reduction in induced flow due to ground effect causes a significant reduction in induced drag, but causes no direct effect on parasite drag. As a result of the reduction in induced drag, the thrust required at low speeds will be reduced. Due to the change in upwash, downwash, and wingtip vortices, there may be a change in position, the installation error of the airspeed system associated with ground effect. In the majority of cases, ground effect will cause an increase in the local pressure at the static source and produce a lower indication of airspeed and altitude. Thus, an aircraft may be airborne at an indicated airspeed less than the normally required. In order for ground effect to be significant magnitude, the wing must be quite close to the ground. One of the direct results of ground effect is the variation of induced drag with the wing height above the ground at a constant coefficient of lift. When the wing is at height equal to its span, the reduction is induced drag only 1.4%. However, when the wing is at height equal to 1/4 its span, the reduction in induced drag is 23.5%, and when the wing is at a height equal to 1/10 its span, the reduction in induced drag is 47.6%. Thus, a large reduction in induced drag will take place only when the wing is very close to the ground. Because of this variation, ground effect is most usually recognized during the lift off for takeoff or just prior to touchdown when landing. During the takeoff phase of flight, ground effect procedures produces some important relationships. An aircraft leaving ground effect after takeoff encounters just the reverse of an aircraft entering ground effect during landing, i.e. the aircraft leaving ground effect will require an increase in angle of attack to maintain the same coefficient of lift, experience an increase in induced drag and thrust required, experience a decrease in stability and a nose-up change in moment, experience a reduction in static source pressure and increase in indicated airspeed. Ground effect must be considered during takeoffs and landings. For example, if a pilot fails to understand the relationship between the aircraft and ground effect during takeoff, a hazardous situation is possible because the recommended takeoff speed may not be achieved. Due to the reduced drag and ground effect, the aircraft may seem capable of takeoff well below the recommended speed. As the aircraft rises out of ground effect with a deficiency of speed, the greater induced drag may result in a marginal initial climb performance. In extreme conditions such as high gross weight, high density altitude, and high temperature, a deficiency of airspeed during takeoff may permit the aircraft to become airborne but be incapable of sustaining flight out of ground effect. In this case, the aircraft may become airborne initially with a deficiency of speed and then settle back to the runway. A pilot should not attempt to force an aircraft to become airborne with a deficiency of speed. The manufacturer's recommended takeoff speed is necessary to provide adequate initial climb performance. It is also important that a definite climb be established before a pilot retracts the landing gear or flaps. Never retract the landing gear or flaps prior to establishing a positive rate of climb and only after achieving a safe altitude. If, during the landing phase of flight, the aircraft is brought into ground effect with constant angle of attack, the aircraft experiences an increase in the coefficient of lift and a reduction in the thrust required, and a floating effect may occur. Because of the reduced drag and power off deceleration in ground effect, any excess speed at the point of flare may incur a considerable float distance. As the aircraft nears the point of touchdown, ground effect is most realized as altitude less than the wingspan. During the final phases of the approach, as the aircraft nears the ground, a reduction in power setting is necessary, or the reduced thrust required would allow the aircraft to climb above the desired glide path. Alright, cool. So that was a ground effect on 4.9 to 4.11. See ya.